Greetings, math friends. Recently, I was looking at a paper on multidimensional inequalities, and one of the things that you had to know was whether your function was considered a convex function or a concave function. So we're going to look at determining that by definition. First of all, we are looking at real functions, so our domain and range is going to be the real number. So we have a mapping, and we're going to choose a function, and we need to choose an interval that we're going to look at the function, and then we need to choose a number between 0 and 1 that's going to kind of be a scalar. The sum of all of these scalar terms should be 1. For convenience, just because it's easy to work with, I'm choosing a half. And then we need to choose two numbers within the interval that we've chosen that fall on the curve. And I'm just going to use -1 and +1. So that's kind of our setup. So I've chosen to do x squared first. And this is our parent function for the quadratic. So we know that this is a U shape. Now when we look at these convex functions, we should be able to draw a line somewhere across the function, and then below that line should lie the turning point for the graph that's going to be our convex function. So this is the anticipation that this is a convex function. So when we substitute our values in here, this should be a true inequality. So we're just going to work through that. We're going to substitute it in, simplify, and see what our result is. The left-hand side here is going to place this whole argument essentially in our function. So we have f of this stuff going on here. So we're eventually going to square that since our function is to square. So I have f of 1/2 times -1 plus 1 minus n times +1. So there's the substitution there. Once we simplify that, we're going to square this. And then over here we have these two are the images of these numbers here. So I'm going to take the -1 and plug it in here. -1 squared is +1. So I'm multiplying by +1 here. Taking the +1, plugging it in here. The image of that is 1 also. So this is what we have, and we're just going to continue to simplify. Now I've simplified this. This is f of 0. We want to know what the image of 0 is. And so we plug it in here. And we find that it is 0. So we have 0 is less than or equal to 1. That is true. This x squared is considered a convex function. That's what I told us that our anticipation should be to begin with. Now, I'm going to use the same givens here, but switch this to a negative so we know it flips the parabola upside down. And I want to run through this again and see the different result. I've added the negative here, so this is -x squared. I'm going to keep the same interval, the same n value, and the same x values here, and then we're going to run through this again. The change starts to begin here. We're going to look for the image of x sub 1. If I plug -1 into here, -1 squared is 1, and then we multiply by the negative here, so this is -1. Over here, to get the image of x sub 2, we're going to plug 1 in here. 1 squared is 1 times the -1. That gives us -1 over here also. So we see a change begin on the right-hand side of our inequality. And we need to continue to simplify because we're going to look for the image of this also. Nothing changed over here, so we know that this is f of 0. Over here we have negative a half minus a half, so we have negative 1. When we plug 0 into here, I get 0 again. So we have 0 is less than or equal to negative 1, and that is not correct. Negative x squared is not a convex function. It looks like this, so this is going to be the opposite. This is going to be a concave function. Hopefully this has been helpful in how you use definition of convex function to work through and determine whether your function is convex or concave. Cheerful calculations.